Okay, here's a little lesson on calculating with rounded numbers. So, here's an example. Jedediah has a painting of his favourite cartoon character. I would have thought everyone's favourite cartoon character. And that measures 90 centimetres by 60 centimetres, with each measurement given to one significant figure. So that's the key information there. The information is that the measurements are to one significant figure. What's the upper bound for the area? i.e., what's the maximum possible area of that picture? Well, ordinarily, when we're calculating area, we'd say it's one length times the other. We'd say it's 90 by 60. But because 90 and 60 are not exact values, then we have to just think a little bit more carefully. Because to one significant figure, 90 centimetres could be as big as 95 centimetres. It could be as small as 85. So to one significant figure, which would be to the nearest 10 centimetres, that would be to the nearest 10. 90 centimetres is between 85 and 95 centimetres. So 95 would be the largest possible length for 90 centimetres. And similarly, 60 centimetres to the nearest 10 would be something between 55, but it could be as much as 65 centimetres. So in actual fact, 95 centimetres and 65 centimetres are the maximum possible dimensions of this picture. Therefore, the upper bound for the area wouldn't be 90 times 60. The maximum possible area would actually be 95 times 65. And that's 6,175 squared centimetres. And similarly for the lower bound, 90 centimetres, its smallest possible value could be 85 centimetres. And that 60 centimetres given to us could be as small as 55 centimetres. So now the lower bound for the area would be the lower bound for one length multiplied by the lower bound for the other. And that's 4675 square centimetres, quite a big difference. So in example 2, a car drove 270 miles in 4.5 hours, but each measurement is given to two significant figures. So 2 significant figures for the 270 miles means to the nearest 10. So 270 could be anywhere from 265 to 275. All right, you have to understand lower and upper bounds for individual measures. And 4.5 hours to two significant figures, that's to the nearest 10th, is anything from 4.45 to 4.55. Okay. Now, given that speed is distance divided by time, the upper bound for speed, we would want the maximum possible numerator, which in this case for speed would be distance, divided by the smallest possible denominator, i.e. in this case minimum time. So if we want the upper bound for speed, we want the maximum distance divided by the minimum time. So you just have a think why in a fraction, to get the biggest possible fraction, you want the biggest possible numerator and you want the smallest possible denominator. In this example then, the maximum distance would be 275 miles and the minimum time would be 4.45 hours, and that would give us, to two significant figures, 62 miles per hour. For the lower bound, the smallest possible value for speed, we would want the smallest possible numerator, so that would be the minimum distance, divided by the biggest possible denominator, so that would be the maximum time. So the lower bound for the speed would be, this time, 265, that's the smallest value for the distance, divided by the maximum time, which is 4.55 hours. And that actually gives us 58.241, so that's 58 miles per hour. So it makes quite a big difference, the maximum and minimum possible values when we've got estimates of measurement. Now here's a table explaining which calculations to use when you're trying to calculate with rounded numbers. So if you want the upper bound of something and you're having to add values together, you take the upper bound of each of the separate values. So that's the upper bound of one value added to the upper value of another, and that will give you the maximum possible value when you wish to add. When you wish to subtract, the upper bound would be the upper value for one, subtract the lower bound for the other. So that's the maximum possible value of one measurement, subtract the minimum possible value of the other. And that's how you would use this table. Now, you can just try and remember this table if you wish, but it's much better to understand why, for example, when you are multiplying and you want the lowest possible value, you need to multiply the two lower bounds of the individual measurements. You really need to understand this table rather than try to remember it.